Hello, welcome to chapter 14. Let me start from the beginning about correlation and regression. Note, here's the homework for our review questions and our exercise problems. And moving on to chapter 14. First two parts we're going to be going over this video, and then I'll have other videos about correlation and regression. Once again, we won't get into all the nitty-gritty within the chapter. We're really going to talk, as this being our last chapter, about the theory and understanding about correlation and regression. We'll be doing the very simple math stuff, figuring out actual correlation, but as we get into the confidence intervals and everything for correlation and regression, we're not going to do the math part, but understand the theory behind it. So getting into our data, 14.1, we have a qualitative response variable of y, which is our dependent variable, and then we also have our quantitative explanatory variable x, which is also our dependent variable. We're going to be looking at public health data set used to illustrate these techniques. So we have 11 countries with our explanatory variable per capita cigarette consumption in 1930, represented as SIG 1930, and our response variable of lung cancer and mortality per 100,000, which is lung CA. So looking at this data, we can go to table 14.2, table for the chart, and we can see our countries, all 11 of them, our cigarette consumption in 1930, and our lung cancer associated with it. So if we were to put these on an XY axis and point dot where these line up, this is the scatter plot of a Dahl's illustration of the correlation between smoking and lung cancer rates. The data points for the United States is highlighted, so that's where the US is. And when we look at scatter plots, when we inspect them, we want to look at the form. Can the relationship be described with a straight or some other type of line? The direction, do the points tend upwards or downwards? And then we want to know the strength of association. Do points adhere closely to an imaginary trend line? Are there any outliers in the pattern overall? And then while we're judging the correlational strength, the correlational strength refers to the degree to which points adhere to a trend line. The eye is not a good judge of strength. As you can see here, there's two scatter plots, and when we look at these, the top plot appears to show a weaker correlation than the bottom plot. However, these plots are the same data set. The perception of a difference is the artifact of axis scaling. So as you can see, as we move in closer to the data plots, you can see our x and y axis are drawn out compared to plots, but these are the exact same plots, and so this is why the eye is not a good test, because it'd be difficult to determine the correlation between these two plots. So this next part is 14.3, and it's very long, and we get into a lot of other stuff. I don't want to split videos up per se, back and forth between the two. So I'm going to make this one super short. But just know that, when we start looking at data plots, scatter plots, to determine if there is a correlation with the data set we're looking at. The eye is not a good test, and we have to actually run correlation itself to get it, and we're going to come up with an R value. I'm going to go into the next videos to talk more about the R value and go from there. I'll see you all in the next video.